talking today about restricted domains. We have three different cases of restricted domains that we deal with. Today we're going to practice finding our restricted domains algebraically. We'll work more with calculators in our next unit. For right now, again, our focus is going to be algebraically. How do we figure out our restricted domains? So pretty much when you are graphing functions and you're given the equation of your function or you're given your function rule, your domain majority of the time is going to be all real numbers. We like to write that notation as XER, but it's going to be all real numbers with the exception of these three cases. So our first case, that is an exception for this, is a fraction. So like, for example, 1 over x. So this is going to end up being a restricted domain because the issue that comes up with this is the fact that your denominator cannot equal 0. You can't have a denominator equal to 0 in a fraction. It just doesn't work that way. You can't divide by 0. Real basic definition of division is you're taking however many items and you're trying to put them into that many groups. So like 6 divided by 2 means you're taking 6 items, you're trying to put it into 2 groups, 3 items in each group. I can't take 6 items and divide them by 0. I can't put it into 0 groups. It just doesn't make sense. It's not possible. So our issue here is we cannot have a denominator that is equal to 0. So in order to find our domain, what we do is we set denominator equal to 0. And then we solve for the variable. And so what's happening when we do that, when we set that denominator equal to 0 and we're solving for that variable, is we're finding what value is not allowed. What value can it not be? So that is what we're doing here in that. So take a look at my example here. We're going to find the domain. This is a fraction, so I'm going to set my domain denominator. We're going to set my denominator equal to 0. Solve for x, so subtract my 6. Divide by 2, and I get negative 3. So the way that I would write this in set builder notation is I would do my x such that I would start off with XER. If you don't remember, XER says that x is an element of the reals, meaning the real number system, meaning it can be any number within that real number system. So this is saying all real numbers here, comma, except that it cannot be negative 3. Because we just found that negative 3 is what makes our denominator a 0. We can't have that. So that is how we would write that in set builder notation. In interval notation, what we would do is you would do negative infinity to 3, and then negative 3 to positive infinity. No brackets because you can't include negative 3 because it doesn't work for negative 3. But that's what we'd write. And you would have to have both pieces. So essentially, what this interval notation is doing is it's skipping over that negative 3 value. So what that's going to look like in your calculator, here's my graph. That value right here, x equals negative 3, what's going to happen is that's going to create an imaginary line, which we call an asymptote. An asymptote is a line that your graph approaches, but never actually touches it or crosses it. So because negative 3 makes our fraction undefined, is the term here, we can't use negative 3. So there's going to be an asymptote on the graph. And then we're going to actually get a graph that looks like this. So let's verify that in our calculator. So I'm going to type into my y equals, I'm going to go to alpha x, 1 over 2x plus 6. I'm going to look at my graph. It's kind of tough to see, so hopefully you have this on your graph as well. But right here at -3, as you can see, this bottom part's kind of going down. That top part there is going up because that's an asymptote. The calculator won't actually draw the asymptote in there. You just have to be able to pick up from the context clues of it's shooting down here, shooting up there. There is an asymptote right there at -3. So fractions is restricted domain number 1. Restricted domain number 2 is a radical. So for example, y equals radical x. So the issue here is that we cannot have a negative under the radical. You can't take the square root of -4. Your calculator tells you there's an error because we can't do square roots of negatives. If you remember the definition of a square root, it breaks it off into 2 equal pieces. So for example, square root of 9 is 3 times 3. It has to be able to give you the same number. So 3 times 3. -9 wouldn't be that way. -9 would have to be a -3 and a +3, so you can't do that because they're not the same number. When you take the square root, the 2 factors have to be the same. So like for example, square root of 25 is 5 times 5. 36 is 6 times 6. So that's why we can do those square roots. We can't do them for the negatives. So what we do is we set this stuff, so to speak, under the radical, greater than or equal to 0. Because we can have it be 0. Square root of 0 is 0. Pretty easy. So it can be equal to 0. It can be greater than 0 because any positive number, yes, just can't be negative. And then again, we solve for the variable. Okay. So take the stuff under the radical sign, greater than or equal to 0, solve for the variable. So for our example over here, 3x minus 3, that's what's under the radical sign. I'm going to set that to be greater than or equal to 0. And now I'm going to solve for my x. So I add my 3, divide by 3. X has to be greater than or equal to 1. So our domain for this in set builder notation is a little easier to write because we don't have to say that it's all real numbers. We can just simply write that x is greater than or equal to 1. Interval notation, that would be bracket 1 to infinity. So bracket 1 to infinity. Then our graph over here, no asymptotes this time. That's not exactly true. No asymptotes this time. Let me keep this color. So our graph's going to start here at 1, 0. And then it's going to go up over there to the right. I can confirm that in my calculator. I'm going to go to my y equals. Second x squared gives us that radical. And again, hopefully you're doing this on yours because my calculator's not showing up too well. But as you can see, it does start at 1, 0. And it goes on to the right. So our domain is x is greater than or equal to 1. So then our third restricted case is when you have a radical in the denominator. So 1 over the square root of x as an example. This really hits both problems. It's a fraction and it's a radical. So it's combining our last two situations that we just had. So our issue here is it can't be negative and it can't be 0. So it can't be negative because of the radical, and it can't be 0 because it's in the denominator of a fraction. So again, just putting them both together. So what we do is, again, we set the stuff, so to speak, under the radical sign greater than 0. We take out the or equal to this time because it's in the denominator of a fraction. We can't have it. And then we solve for the variable. So set the stuff under the radical greater than 0, solve for the variable. Looking at my example over here, my stuff under the radical greater than 0, I'm going to solve for x, and I end up with x is less than 6. So then again, set builder is pretty simple this time. X such that x is less than 6. Interval notation would be negative infinity to 6. So checking it in the calculator, alpha x, 1 over the square root of x minus 6. Oh, that helps a little bit. There we go. And a little too bright. So if I look at my graph, this is what we get. So we've got right here, and then it kind of brings its way down. And it's never going to be to the right of 6. It's always going to be to the left of 6, and it does keep on going forever there.